How to draw a Lewis dot structure for any atom. Science students are regularly asked how to draw the Lewis dot structure for molecules. We will take you through how to make such a structure in this video. But before we get into that, let's first take a look at what a Lewis dot structure is. A Lewis dot structure is the visual representation of an atom's valence electrons shown by dots. Valence electrons are located in an atom's outermost energy level and are responsible for that atom's chemical behavior. To find out how many valence electrons an atom has, consult a periodic table of elements which indicates the number of respective valence electrons. With this information to hand, you can easily draw a Lewis dot structure. Let's see how this is done in more detail. Here are the steps to draw a Lewis dot structure. First, identify the number of valence electrons in an atom. Then, write the chemical symbol of an atom and draw a single dot for each of its valence electrons around the sides. Make sure to place an equal number of dots on each side. Okay, let's now draw a Lewis dot structure for boron trifluoride, or BF3. This requires 4 pieces of information: the total number of valence electrons, the required number of electrons to complete an octet, the number of pairs of bonding electrons, and the lone pairs, which are the non-bonding pairs. These pairs appear when electrons do not participate in the formation of bonding between atoms. So, in the case of boron trifluoride, boron and fluorine have the atomic numbers 5 and 9 respectively. The periodic table indicates that boron has 3 valence electrons and fluorine has 7. Since there are 3 fluorine atoms, the total number of valence electrons is 3 plus 3 times 7 equals 24. For each atom to share the required number of electrons, boron must have 6 electrons in the outermost shell, and fluorine must have 8 valence electrons, i.e. a total of 6 plus 8 times 3 equals 30. The difference between valence electrons and required electrons is 30 minus 24 equals 6. Each bond needs 2 electrons to form, so the number of bonds equals half the number of electrons required, or 6 divided by 2 equals 3. Now, calculate the difference between the number of valence electrons and the number of bonding pair electrons to get lone pairs. 24 minus 6 equals 18, i.e. 9 lone pairs. Now we have gathered all the information, we can draw a structure. In order to do this, choose the central atom. According to the arrangement of elements in the table, boron is the least electron-negative of fluorine. Therefore, boron forms 3 single bonds, 6 electrons, with fluorine's atoms. Now you can assign the 18 remaining valence electrons so that each fluorine atom has 6 electrons surrounding it. According to the octet rule, each fluorine must contain 8 electrons to complete the octet, and the boron must include 6 electrons for their stability. The octet rule states that atoms are most stable when their valence shells are filled with 8 electrons. Fluorine has 6 electrons, which is a rare case in boron. Fluorine also completes its final shell by forming a bond with the electrons of the boron. Let's just summarize what we now know. The Lewis dot structure allows visibility of all electrons and determines if an atom follows the octet rule. Molecules can have both bonding and non-bonding electrons. Knowing the Lewis structure of an atom permits an understanding of how it will bond and how many bonds it will form. This knowledge enables us to understand the shapes of molecules and their chemistry.